Hi, I'm Russ Nelson, and I've invented a local positioning system for an automated lawnmower that I'd like to demonstrate for you. First, I'd like to describe how it works.
My local positioning system uses two locating transmitters, sonic or audio transmitters, to locate an automatic lawnmower relative to those transmitters. It does so by triggering each transmitter sequentially with a frequency shift keyed FSK RF signal or pulse from the mower. The first sonic transmitter is triggered by the rising or positive edge of this pulse, while the second sonic transmitter is triggered by the falling or negative edge. The importance of this triggering method is a couple of surprising novel and unobvious results, namely the reduction of elements or parts in the system. The FSK RF signal also solves the problem of trying to trigger the sonic transmitters with a digital trigger pulse every second or so. The particular RF receivers involved need to have a transition every 33 milliseconds or less, or it loses signal veracity. I talked with the manufacturer of these receivers and they could not offer any solution to that problem, but simply said it couldn't be done. Well, I believed it could, and I did it, so you can see this in the demo shortly. Even more important is the effect of temperature on the accuracy of the distance measurement and consequently the XY coordinate. But I will say more about that after the demo. In the following demo, you will hear some spurious sounds from one of the transmitters. I later discovered that the RF receiver in sonic transmitter T1 was very marginal, so it produced a little noise. The system worked in spite of that, but I have since replaced that faulty part. So let's go ahead and take a look at this demo. It's just a short, simple, straight line.
I'm just going to get this in place. Okay, this is Friday, December 17th, 2010. This is the first operation of the lawnmower that operated correctly and following a recorded path. The recorded path has already been made, and here are the two transmitters, one here, T1, and one over here, T2, and it has followed the path, so we're going to take a picture of that operation. I will select it on the panel. Path 1 has been selected now, and we're going to turn it to start, and it's in auto. Here we go. What it will do, we'll read the path file, then it will move a certain distance, a short distance, to establish its initial orientation, and then it will proceed to follow the path and then stop at the end of the path. When it gets an error from one of the transmitters, it will stop until it gets a good signal, and then it will continue. And there it stopped. Completed its path. Again, a successful operation of remote and automatic operation.
The most important element of my invention is that I account for the variation of speed in sound in air because of temperature. The path I recorded was during December of last year. The temperature then was about 40 degrees. I ran the automatic mode at that time too, but when I run it in automatic mode, say on a hot summer day at say 90 or 100 degrees, the distance measurement and consequently the XY coordinate calculation can be off by as much as 6.7 feet in an area of 100 foot square. The resolution of the least significant bit of a counter can be less than a fraction of an inch, so that kind of error is unacceptable. The prior art has not even recognized that problem. The one reference that did mention temperature effects taught away from it, saying that it was not important. Well, it is very important, and no one accounts for temperature, but I do. So my system is simple. It works, and it produces surprising and unexpected results. My mower moves a little slow, almost as slow as the rovers on Mars, but that just means it needs a little more powerful motor than a 1/30th horsepower motor. Thanks for watching.